We're going to learn to apply properties of numbers and find counterexamples. But first, let's take a look at at properties of numbers. The commutative property. It works kind of like a commuter for work. If your parents drive somewhere to work and then drive home, it's the same route that they take both ways, just a different order. Associative property. If I wanted to get a count of all the football players and the volleyball players and get a total for that, but instead of putting them as football and volleyball players, I want to get a count of them as freshmen, sophomores, juniors, seniors, still the same kids, just associating them into different groups, still get the same total. Distributive property is for multiplication when you have a number out in front of parentheses and you go ahead and distribute that number by multiplying it to everything within the parentheses. Identity property, there's two of them. For addition, we would add 0. 7 plus 0, or any number plus 0, will still be that number. For multiplication, we would multiply by 1. 8 times 1 is 8, or any number times 1 will still be itself. And then we have one special 0 property. 9 times 0 is 0. Anything times 0 is 0. You guys have to excuse my kids for this lesson today. Two vocabulary terms, conjecture and counterexample. We'll get to those a little bit later. First off, if we're reading math, there's some important ways that we would read it. Equivalent expressions have the same value, no matter which numbers are substituted for the variables. Let's do some examples of those. Use properties to determine whether the expressions are equivalent. I have two expressions, 7 times x times 6 and 13x. I'm going to rearrange that first one using the commutative property in order to see if it's the same. I'm going to move the 6 over to the 7 and then go ahead and multiply my 7 times 6 using the associative property by grouping them together. 7 times 6 is 42, and 42x is not equivalent to 13x. Let's try another example. I have 5 times the quantity of y minus 11 and 5y minus 55. I'm going to use the distributive property for this one using the first expression and distribute that 5 to each term within the parentheses, the y and the 11. Now when I multiply that out using order of operations, I have 5y minus 55, which is equivalent to my second expression. So those two expressions are equivalent. Let's see where we might use this in the real world. Remember, we're all consumers, we all purchase things. During the last 3 weeks, Jay worked 26 hours, 17 hours, and 24 hours. Use properties and mental math to answer the question. How many hours did Jay work in all? I know this day and age in technology, you might not all use mental math, but this is how Mrs. Noble uses some of these tricks that we will work on this year. To find the total, we need to add them together. So in the order they're listed is 26, 17, and 24. I'm looking for combinations of 10. 6 and 4 in the ones place of 26 and 24 is a total of 10. I'm going to put those together using the commutative property, and then lastly using the associative property, I'm going to add them first. 26 plus 24. If I just, let's get my mouse out here, if I just look at the 4 in the ones place and the 6 in the ones place, that adds up to 10. Then I'm just going to add 20 and 20. 20 and 20 is 40. 6 and 4 was 10. That's 50. So I can add 50 plus 17 in my head is 67. Since it's a word problem, let's make sure and use the correct notation, units, and labels. Jay worked 67 hours in all. Well, I kind of want to know how much he made. If Jay earned $7 per hour, how much money did he earn for the last 3 weeks? I can use my 67 hours from the last application, and I'm going to multiply to find my total. 7 times 67. Again, this day and age in technology, you could go to a computer or a calculator, but there's a simple way to do this. 67 is really close to 70, so let's break that apart into 70 minus 3. These numbers I can do mentally. 7 times 70. 7 times 7 is 49 with a 0 at the end. 7 times 3 is 21. So using the distributive property, I break that apart. 490 minus 21, and I can get an answer of 469. Again, it's a word problem. Let's make sure and use the correct unit. So Jay made $469 for the last 3 weeks. Now let's get to these vocabulary terms of conjecture and counterexample. A conjecture is a statement that is believed to be true. A conjecture is based on reasoning and may be true or false. Sometimes in math we call these rules. A counterexample is an example that disproves a conjecture or shows that it is false. One counterexample is enough to disprove a conjecture. So let's look at this problem. Find a counterexample to disprove the conjecture. The product of two whole numbers is always greater than either number. The product is a multiplication problem, and I want to know that when I multiply two numbers, it's always greater. Well, 2 times 3 is 6. I always use little numbers, but I think I have an example that might work. What if I'm multiplying by 1? This is one of our properties, our identity property. 2 times 1 equals 2. 2 is neither greater than is not greater than either of the numbers in the original problem. So since the product is 2 and it's not greater than either of the whole numbers being multiplied, this is a counterexample, disproves the